Now welcome back to our afternoon section, which is the panel discussion. Now let me give it back to my co-host Huayin. Are you there?
That's, I think we can, I can start as well. Then I guess in that case, I'll probably just introduce myself very briefly, and once Professor Guo joins, he can let me know. So I am Huayin Tang, Secretary General and Vice President of the UKCSAE. I have worked in the automotive industry in both China and the UK, and currently my role is Principal Engineer at McLaren Automotive, looking after electronic and control software system for battery management, motor control, power electronic control, and vehicle control. And together with me today, the co-host is Professor Yue Guo, who looks after the energy storage system at Coventry University. And we've got a number of panelists with us. And before we start to introduce them,
apologies for interruption. Can you hear me now?
Yep, no problem.
Apologies, everyone. Sorry for the technical difficulties I had earlier. So good afternoon and good evening. Huayin, would you mind me taking over to do my introduction?
No problem. Yeah, I've just introduced myself briefly, so you can go for yourself.
Okay, thank you.
Don't worry.
So my name is Yue Guo, and together with Dr. Huayin Tang, and on behalf of the UK Chinese Society of Automotive Engineers, we would like to welcome all of you to this panel discussion on the topic of the new energy vehicle development. And thank you to all the panelists for your patience, and apologies again for the delayed start. So we will carry on the same format of the last panel discussion. To begin with, I would like to briefly introduce the panel members and also the moderators. I will then ask the panel members to offer some insights on the new energy vehicle development based on their experience and expertise. So we will then throw out some questions to the panelists to kick off the discussion. For our audience, please do feel free to put forward any questions you may have through the chat box. We will open the floor and pick up some of those to answer at the end of the session. So please note, this panel discussion will be conducted in English, but the English to Chinese translation is available as in the earlier sessions. Please do make use of the button at the bottom of the screen to select the audio channel as you need. So there are two moderators, that is myself and Dr. Huayin Tang. So for those who have managed to join us in the morning, you already know Dr. Tang, who is the Secretary General and Vice President of the UKCSAE. He has worked in the automotive industry in both China and the UK. His current role is Principal Engineer at McLaren Automotive, looking after electronic and control software system for battery management, motor control, power electronic control, and vehicle control. In terms of myself, my name is Yue Guo, and I'm Professor of Battery Systems at Coventry University in the UK. I'm also a committee member of UKCSAE. At the moment, I'm involved in multiple research projects on the design and the development of the energy storage systems for low carbon transport applications. These include system modeling, robust design, and validation of automotive electronic system, advanced testing techniques applied to lithium-ion batteries. Now, I feel deeply honored to introduce our distinguished panelists. We have Michael Miller, Vice President, New Energy Vehicle at Ricardo Asia. As a brief introduction, for those who didn't have the chance to join us in the morning, Michael has spent 25 years in NEV development, starting from General Motors on the EV1 in 1995. With global experience from North America, that is 12 years, and 3 years in Europe, and 10 years in China, developing new energy vehicle that includes battery electric vehicle, hybrid and fuel cell vehicles, working on advanced prototypes through to production for vehicles and the key components, including batteries, e-machines, and inverters. We also have Mike Bassett, Head of Research at Mach Powertrain UK. Mike studied mechanical engineering at Bristol University, followed by a PhD at UMass, focusing on modeling of IC engines. Mike then joined Lotus Engineering. He moved to Mach Powertrain in 2007 and is head of research and responsible for global research activities, focusing on both IC engines and electrified mobility. A huge thank you to both Mike and Michael for staying with us through the day. Thank you. And also we have Professor Jianbo Zhang from Tsinghua University, who is a director of Automotive Powertrain Institute. Welcome, Professor Zhang. Professor Jianbo Zhang received his PhD degree on aerodynamics in the University of Tokyo, Japan. He worked in Nissan Research Center on the R&D of fuel cell and the lithium-ion battery during 2000 to 2011. He was offered the professorship in the Department of Automotive Engineering, Tsinghua University, China, and set up the lab of electrochemical power sources in 2011. We also have Tom Xiaofeng Zhang. Good to see you again, Tom.
Hi, good to see you.
Tom is the Commercial Operations Director from Protein Electric. Tom Xiaofeng is a British-trained Chinese automotive engineer. He is passionate in application and the commercialization of advanced powertrain techniques. In Chinese market, he has previously worked for senior technical and commercial roles at Automotive and Ricardo UK. He is now the Director of Commercial Operation in China, Protein Electric Limited. Last, but definitely not the least, we have Adrian Del Mastro, who is a Director in PwC Strategy Consulting. Adrian leads the firm's global thought leadership in energy, as well as advising clients on strategy. One of his areas of focus is EV charging, where he has advised multiple energy companies on market entry strategies. Right, having introduced the panelists and the moderators, let's now dive into our topic. So the new energy vehicle development is becoming increasingly complex and challenging. And that's why you may have noted already, we have a group of panel members to discuss this topic from different perspectives. For example, we have Professor Zhang from Tsinghua University representing the academic community. We also have the engineering consultancy companies to look at the NEV R&D from the industrial perspective. We have Protein Electric, a relatively young company that is committed to develop novel components for new energy vehicles. In addition to that, there are companies that many of you, including myself, may not usually link their typical business with new energy vehicle industry, such as PricewaterhouseCoopers, that is PwC, as people commonly know. So Huayin, would you like to bring up the slides and introduce our first talk, please? Thank you.
Yeah, no problem. Thank you, Professor Guo. So before we kick off the presentations and the talks, I just my personal feeling about the session we're having now. So we have 5 senior professionals from the industry, and if I use kind of a typical V process to explain how we can make it make the story flow. So if we consider Adrian to represent the customer and user experience perspective from the top of the V, and then Michael and Mike looking after, for example, the systems for the powertrain, which is maybe somewhere at the middle of the V. And then at the bottom, we have the component supplier, protein, electric, and also Professor Zhang looking after the research of the very detailed cell development. Personally, I feel like this is a great panel for a discussion on this topic. So I'm very much looking forward to this. And maybe first, if we follow the V process, I would like to introduce Adrian. And we all know that currently the electric vehicles have a lot of challenges, including, for example, range, obviously. And in order to tackle the range challenge, the charging infrastructure and the charging rate are big enablers. And I know Adrian has a lot of experience on these topics. So yeah, Adrian, please share with us your expertise.
Thank you very much. And hopefully you can see me and hear me clearly. Firstly, really kind of you guys to invite me to your event. I'm honored to be with the panel. And just on a personal note, I hope everybody and their family and friends are well and safe in these difficult times. When I was approached to speak about this topic, it was great to see so many engineers talking about the EV side of the equation. But as Dr. Tang has just kind of alluded to, it's a symbiotic relationship. You need the infrastructure in place to help accelerate that electric vehicle adoption. And what I was keen to do was get across two simple messages. One is a very parochial one around the UK EV charging market, which is to say that it's a vibrant charging market and an interesting one, and in many ways a model for other markets. And I'll talk a little bit more about that in a second. And I think the second message I want to get across, that when you look at all the different types of EV charging models and pathways, I think fleet charging is going to be a big catalyst in mobility transformation, particularly in the UK, which I'll talk about in a bit more detail in a second. So if we just turn to the first slide, if you just flick over, thank you, just the next slide. This is a busy slide, but this is a snapshot in a way of what's happening in the UK. The left-hand side talks about market developments. The two graphs in the middle show the size of the EV stock and chargers, publicly accessible chargers. And on the right-hand side, I've got some comments around some of the challenges around EV charging. So on the left-hand side, I think the key messages there, pretty good government support, I think, in terms of investment in EV charging. So the government has invested some 500 million this year to support the national charging network. They've extended the grants for battery electric vehicles. There's a lot of talk about bringing forward the ICE ban, which originally is 2040, to potentially 2035 or 2030. And we'll see what happens in the next few weeks, which one of those dates land. And even small things such as the introduction of green license plates, just to raise awareness of EV adoption. In terms of foreign investment in the UK, I always think that's a very good indicator of the health of a sector. And earlier on this year, you had EDF acquired PodPoint, which is a charge point operator, one of the largest ones that are an integrated player with pretty much a national footprint, and Pivot Power. And this acquisition is not too different from BP in 2018 when they acquired ChargeMaster. So big investments there. Note Total, another oil and gas company, is a theme here you'll see, recently acquired Source London, the EV charging municipal network provider. And what's interesting there, just as, and we can talk about this later, is just the oil majors, not only are they developing EV charging businesses, but they're setting targets, some of them, about meeting certain numbers of charge points in the future. The other element about the UK, I think, is particularly interesting are the partnership models. So a lot of these charge point operators have to form partnerships to get the scale. And you've got examples there with Instavolt partnering with McDonald's to use their retail outlet to install rapid chargers. New Motion, owned by Shell, formed a partnership with the supermarket chain Aldi. BP recently announced with Uber that they would help electrify their taxi fleet in London. And even an interesting one at the beginning of the year, Liberty Global Ventures, that owns Virgin Media, partnering with Zook to provide off-street charging using the Virgin Media duct network. And a nice example there of that theme of convergence, where you have automotive, telecoms, and then some of these other examples, energies companies converging on mobility. Clearly, COVID-19's had an impact. In the early phases of the lockdown, some of those non-essential installations were paused. But I think you only have to look at, for example, GridServe, that will be hopefully opening the first EV electric only forecourt at the end of November. And you look at the registrations of battery electric vehicles and plug-in hybrid electric vehicles in September, they all grew significantly while diesel and gasoline registrations declined. So still a robust sector there. The charts in the middle, I'm not going to dwell on, just simply to say that you see the EV stock growing at a pretty robust rate there in the UK, and the public charging network, roughly at half the rate. So it's still trying to keep up. But I think, to what Dr. Tang kind of alluded to, there are still some issues around EV charging, which are range anxiety, and sometimes I like to refer to it as perceived range anxiety, because most of the premium electric vehicles have 300-mile range, so it's not an issue. But there is still a kind of residual worry about how do you charge, whether you will run out of power when you drive an electric vehicle with consumers. There is still, particularly in cities, concerns around access to infrastructure. So if you're in a city, you're less likely to have off-street parking, and that could be a concern. And I still think there's an issue around for consumers' choice and affordability, particularly in that middle range there of electric vehicles. You have the premium, you have the slightly more competitively priced electric vehicles. There's not a huge amount of choice in that middle section, and affordability as well is an issue. Particularly, we still have a very nascent second-hand car market. And I think when you look at those arrows underneath that circle, all that's trying to say is right now in the UK, you've essentially got 4 different ways of charging. You have home charging, workplace charging, destination charging. Think of leisure centers, cinemas, supermarkets, and rapid charging. These are all different plays, and different charge point operators are focusing on either all of them or some of them. It's likely that home charging will play a big part in the initial phase, just because where people have access to off-street parking, it's probably the easier way to charge your vehicle. But none of these are dominant plays, and they will evolve. And clearly, there's always the risk in all these types of plays about the impact of technologies. And just to mention one, wireless technology induction charging, that's something in Norway that's beginning to be piloted. I'm not sure it's going to displace traditional forms of charging, but clearly there are other technologies out there competing. And my final comment, if we just go on to the next slide, we do think that fleet charging is going to be transformative, particularly in the UK. And when I talk about fleet charging, I'm talking about corporate car fleets, logistics deliveries, or the vans used by utility engineers. That fleet in the UK numbers round about just over 5 million vehicles. And many of those fleet owners are beginning to electrify their fleet. So they're at a very early stage, but the majority have already started setting targets. And when you consider that fleets have that enormous scale, plus they dominate the sales, UK car sales, over half are from fleets. If you can electrify that fleet, you have 3 major benefits. One is you get scale in your electrification of mobility. So, some of the forecast scenarios look at around about 12 million vehicles by 2030 in the UK. If you electrify the fleet, you're going to get a substantial way forward from that. I think the second thing is the nature of the fleet. As it electrifies, it'll generate a second-hand car market, which will be very good for consumers for more choice, and clearly added benefits in terms of air quality. So I think I'll finish on B2C charging. There's been a lot of focus on that in the UK, And some have described it as a little bit of a land grab as charge point operators seek out positions. I'm not convinced that that's a profitable business model just yet, but it needs time. But we do see that's an important part of the equation, but we do also think that fleet charging, as it takes off, will build that necessary momentum for electric vehicle adoption in the UK. So I'll end on that note.
Thank you, Adrian. Thank you for your insights on the charging infrastructure. It's certainly a very important consideration from the customer perspective when purchasing an electrified vehicle, how easily it can be charged and how quickly it can be charged. I guess the other consideration, or sometimes could be a concern to some of the potential customer, is the safety of the electrified vehicles. Next question, I would like to ask Michael from Ricardo. So Michael, you talked about how Ricardo as a company reacting in a fast changing industry at a difficult time this morning. If we can now pick up the topic of the complexity of EV, which consists of energy storage system, power electronics, motor with large amount of sensors, this is even more challenging on hybrid vehicles as there are multiple systems must be integrated and functioning in parallel. So could I ask you to offer some insights from your perspective about how could we manage the failure mode analysis on the functional safety to achieve robust and cost-effective design? Thank you, Michael.
Sure. So I guess let's start with the, let's say at the system level, the EVs become, let's say at first glance, simpler, and in many aspects, they are simpler than an internal combustion engine, but they are very different in the risks and the challenges that come with them are, let's say, much less familiar than the internal combustion engine. So you're driving around with a tank full of petrol, highly flammable substance. There's inherent risk with that, but we're all comfortable with it. Now, batteries, and especially batteries with respect to the safety implications, they pose a new challenge. And currently, the higher energy density batteries also are coupled with being a bit more, let's say, a bit less safe, or a bit, let's say, lower thermal runaway issues. So managing the implications on, again, especially the battery, which will be driven by rapid charging, thermal management, propagation of fire across cells, starts to get really quite challenging, and we don't know all of the let's say the best mitigations for doing that. You still see battery fires across the board for EVs that are out there, but again, hopefully getting fewer and fewer as we understand better how to mitigate those things. The best way to approach the functional safety aspect is going to be through mitigation rather than prevention. So good, strong engineering purposes, our engineering process to go through the DFMEAs and clearly define what all the risks and hazards are. And let's say maybe one of the bigger challenges, especially for OEMs, is understanding the implications of those challenges that come from outside of the component itself. So you can have the people who know the battery, typically a battery supplier, and then you have the people who are developing the systems around to protect the battery, and they don't necessarily know the details of the battery and the risk factors within the battery nearly as clearly as they should to make it an overall safe system. And that's where we have to make sure that we get good engagement between the electrochemists, the thermal system engineers that are working with the battery, and for the other systems around the battery, the charging systems and the charge rates that are acceptable and how to manage that and mitigate that, to keep the temperatures down in the pack, to stop the deterioration of the cells and driving it towards the risks of thermal runaway. Now, most of that should be captured through a proper functional safety process as generally outlined in 26262. But following that process doesn't get you there. You really need strong engineering background in all of the areas to go through it. And I have to say, I've gone through many DFMEAs on many of these types of vehicles. And at no point have I ever felt that we've had truly enough knowledge and insight into all of the aspects of the vehicle to really do it proper justice. We have a great deal of experience all around, but it is a vastly complex system with a lot of still unknowns in the technology as we go forward. So obviously the 26262 process is the best process we have, but it is a process and it is a general process. And we can't get away from the strong need for a system level knowledge and the detailed level knowledge in order to do the failure analysis or failure mode analysis properly. So please stop there, but I can go on for hours if you like.
I won't be surprised. And also, I hope you would agree that the safety is a challenge can only be addressed from the system engineering perspective. It cannot be looked at in isolation from a certain component point of view.
Absolutely. And I say, I hope that that's the key message that I can get across is we do understand, I say most specifically batteries, but also electric machines, and but how that all fits together and how the use of one thing impacts the failure modes of the other. That's the place where we seem to struggle the most to get that all tied together. Especially most OEMs are looking at, I want to buy this component and that component, and then I want to hook them together. But the system engineers don't have enough depth in their knowledge to understand the implications of both. And that's the place where we really have to improve, I feel. As an industry, moving away from buying bits and bolting them together and really focus on how do I integrate everything together so it works seamlessly.
Excellent. Thank you so much for your input, Michael. And I would like to pick up hybrid vehicle as it is a very popular topic, especially gained loads of attention recently. And Dr. Mike Bassett, could I ask you to share some of your thoughts on the hybrid vehicle powertrain, please? And also, I noted this morning, due to the limited time, you probably didn't finish everything you prepared to talk about. Would you like to continue where you left off, or feel free to kick off that conversation on the hybrid powertrain, whichever way you would prefer?
Okay, thank you. Can you see my screen?
Yes, I can. Thank you.
Okay, so yeah, I think this follows on quite nicely from what Michael was just saying, where we need to consider the whole system rather than bolting pieces together. And this is our view of potential future hybrid powertrains, where we've looked at the potential synergies of incorporating the electric drive with a conventional internal combustion engine, and looked at how we can maximize the benefits of both systems. And it's a nice showcase of Marler Powertrain's engineering capabilities. And this has been done with teams from across the globe, working in our offices in North America, in Germany, in the UK, and also in Shanghai. And we started to look at driveline architectures around parallel and series hybrids and the attributes of those. And actually, the series hybrid has some benefits over a conventional parallel hybrid because the engine's decoupled from the wheels, and you can optimize engine operation much more freely than with parallel hybrid. But the parallel hybrid offers much greater cruising efficiency. Actually, converting mechanical power via a shaft to mechanical power at the wheels is more efficient than going through an electric drive system. And that's led us to combine the benefits of the parallel and series hybrids by adopting a dual mode architecture, where we have the ability to run in series or parallel mode. So the architecture we selected with a small optimized engine with a integrated generator and a multi-speed transmission, allowing us to connect the engine to the wheels. Gives us pure electric mode when we select neutral in the transmission. We have a very simplified transmission with 2 pairs of 2 speed ratios that are sequentially selected, very much like a motorcycle transmission. So very low cost transmission with no clutches, and we disconnect the engine by selecting neutral, and then we can run in a series hybrid mode with the engine still in neutral but running the engine and generating power with our generator. And then we have a direct drive mode, and we use the transmission ratios to enable flexibility of engine operating speed and power outputs with different vehicle speeds, so enabling us to accommodate steep gradients or towing scenarios. So the transmission that we've designed and developing has integrated electrical machines, the generator and the traction motor and their respective power electronics, and within a common casing we can adopt a 1, 2 or 4 speed gear set depending on the application, which gives us a low cost, compact and adaptable transmission. We've also developed a dedicated hybrid engine for this application with very much reduced complexity, and it also uses a pre-chamber jet ignition system, so very much like the system used in the Formula 1 engine that Prof. Cheng showed earlier today, and gives us very high efficiency at low cost. So the pre-chamber combustion system gives us very reduced burn durations, enables increased EGR tolerance and extends the knot limit, so we can run very high compression ratios, in this case 15:1, even with port fuel injection. And that's enabling us to achieve almost 41% brake thermal efficiency with a very low technology package. So for many applications, we see plug-in hybridization as a good stepping stone towards full electrification, because it enables local emissions-free driving and long-range capability with a small battery pack. So our concept is cost optimized and integrated. It achieves very high efficiency from the engine through our jet ignition system, and we have developed a scalable multi-ratio transmission with integrated traction motor and power electronics. And one slide from earlier that I did omit, that's probably worth touching on, is looking at the benefits of PHEVs in real world compared to their drive cycle fuel consumption. And the graphs here show China and Germany. This is taken from an ICCT white paper, so the International Committee on Climate Change. And what this is showing is that the fuel consumption that is expected based on NEDC testing isn't being seen in real world. Actually, in China, we're seeing up to about 400% more fuel being used, so 4 times the amount of fuel. In Germany, the picture's closer to the NEDC test, so about 250% of the test fuel consumption. But actually, this red portion shows company car users who often adopt plug-in hybrids for tax reasons, but also potentially get free fuel as part of their car package and have no incentive to plug in. And they're doing less well with their electric driving and using more fuel. But what's interesting is if you dig into this data and look at the electric driving range of the vehicle, actually the users with vehicles with high electric driving range are plugging in more frequently and getting much closer to the figures measured during NEDC testing. So getting closer to this electric utility factor curve, with 100% being fully electric driving and 0 being fully gasoline driving. So what we see is that actually the longer the electric range of a PHEV, the more the benefit the consumer perceives and the more incentive there is for them to plug in. If we look at the same data for the company car users in Germany, we see there's many cases where the user isn't plugging in. They're incentivized to drive on gasoline by having free fuel available potentially. So these are the wrong user base for these types of vehicle. And the ICCT's recommendation for PHEVs is actually we should increase electric driving range from typical of 50 kilometers today to about 90 kilometers or more in future years. Thank you.
Thanks, Mike. As you mentioned just now, many people view hybrid technology as a stepping stone towards the full electric vehicle. I guess the difference is the duration, about how long that technology will have to exist in different markets. In case you haven't heard about it already, there's a shift to the technology roadmap in China. And as a company who have invested a huge amount of resource and also process of the wide range of the hybrid technologies, you may be quite pleased to hear that latest change in the technology roadmap published in China. But I do only want to tease you a little bit and I save a question for you to answer later on. And I'd now like to ask a question to Tom, please, if you wouldn't mind. Tom, so when we're talking about new energy vehicle industry, there are some companies or some people we just can't avoid to ignore. For example, Mr. Elon Musk and also Tesla. And as we all know, they have made some announcement recently on their future development. It seems really, I would say, ambitious or aggressive. Do you have any particular view on their technology roadmap? And also, from the Putin perspective, would you look at Tesla as a pioneer or potentially a competitor or a collaborator for the future?
Okay, thank you. Right, so first, good afternoon all. I would like first congratulate the UK Chinese Society of Automotive Engineers reaching its first anniversary. So exactly 1 year ago, I had the honor to be invited to speak at its founding ceremony in London. So I witnessed so many young engineers join the society to seek knowledge and to make friends. It is truly a home, becoming a home for all the UK automotive engineers. I'm also very pleased to find out that we have now over 400 registered members as today, and it is a great achievement by the society officers and the committee members. So very well done. So so second point I want to make is I joined the Protein about a year ago. So I'm commercial operation director at Protein Electric. It is a UK Surrey-based technology company who specialize in design development of in-wheel motor technologies. So actually the company is now part of a Chinese company called Evergrande Group and Evergrande Auto. So Henda汽车, that's that you may see the news. So it put me in a fortunate position to witness kind of the birth process of a cutting edge technology in the UK, and also practice that, commercialize that at the most buoyant market in the world, which is China. So I'm in a very privileged position. So Tesla is a great question. Clearly, the leaders and the politicians and also industrial leaders in China believes that introduce Tesla to China, to Shanghai, is going to bring a catfish effect to the industry in China, to help us and the industry to revolutionize. I think it has done exactly that, maybe even more. I think the market is under stress, but more positively than negatively. But if you look at the market share, if you look at how our industry behaved, or the car industry behaved in China, when we had Japanese and European and US OEMs taking majority of the market. But then you look at today, we have more than 5, maybe even 10 startup companies, or who are selling high quality electric vehicles in China and competing with Tesla. So I'm quite encouraged by that. Protein, as part of Evergrande, we are involved in a lot of discussions about what an electric car should be like. What we need to do to actually to compete and even overtake the leadership that Tesla has built itself over the last decade. To be frankly, it's quite tough, but we like to think two things, right? So one part is the shield, another part is the spear. So the shield is the fundament of the car. So the mechanics, the electronics, the batteries, what makes the car work, function as a transportation tool. But the spear is going to be in the software. It's in the electronic architecture. It's in the software, the ability to sell service once the vehicle is sold to a consumer. So we have to work on the both ends over time to have a full competition with the best in the market right now. One of the options and one of the possibility is to use wheel motors, right? It's not myself trying to sell or trying to promote the technology. It's just the idea, right? So you have to think about I think there's well, probably most of our industry is focused on the energy itself, right? Energy to generate electricity, to reduce carbon emissions, to store the energy and deal with associated challenges and problems like safety is extra and XYZ. But what we haven't really thought about is that a vehicle, the design the fundamental purpose of a vehicle is to transport people and goods, right? And what we need is that space to transport people and goods. So we think that there's a lot of things that that like us engineers can do, that we can use, for example, the wheel motor technologies to generate space in the vehicle and to create a complete new species of vehicles for the car industry. And that would accelerate not just inching forward, but to actually to leap forward into the battery EV era. Okay. Yeah, surely we can talk about that more, but that is, I don't know if that answers your question, Doctor.
Thank you. You answered exactly the question. And I also actually have a follow-up question, if you wouldn't mind. From what I can see, Protein and also Hengda汽车is fully committed to the full electric vehicle. And also from the news and also the latest development I can see at Protein, you are looking to lead a revolution, not just the evolution. Is that correct? Is that a fair comment?
So there's depends on which angle you're looking at. So when I was, Dr. Guo, we went to the EV100 earlier this year, right? In Beijing, and it was an eye opener. It was my first time here. What I learned, what I took away from that conference, the biggest thing I took away was when we talk about innovation, it's not just the technology itself, but it's also the business model, right? So I think China the government has got a never fading northern star and guiding the industry forward, but not just how to make a car, but also the intelligent cities, the power generations, and has all that areas covered. So what Evergrande is trying to do is not just focus on it's not just focus on the car itself or using its scale of economy benefit, advantage to undercut. But what it's trying to do is it develop a relationship and a partnership with National Grid, right? Because its ability to, well, Evergrande sell 800,000 apartments in China, right? And it owns most of the maintenance and service of the, what's that? That's what do we call in English? The 小区,
estates.
Yeah, the estates, right? So it actually, since 2017, they have starting to upgrade the electric infrastructure in the residential areas to be prepared to electrify people's need or people's use of electric vehicles. So and on top of that, they are investing in development of the powertrain technologies, the battery technologies, and also the vehicle itself. So it is innovation, in my opinion. It is innovation, maybe a renovation in the business model itself, because it listened to the government. It took a different approach to as a startup into the market, step into the market. Okay, and yeah. So if you like to, to answer your question, I think it just really depends on which angle you're looking at.
Right. And also, I guess, incorporating the charging infrastructure within the new state development could be a successful business model for something to talk about with UK companies. Maybe there's a lesson that could be learned together in both countries. Or maybe it was having the conversation with Adrian to say whether there's something you could work together. and also, well, I already asked quite a few questions. And Tom, final question for now, if you wouldn't mind. I just wanted to ask, from your company perspective, is there any plan or initiative to develop alternative propulsion system apart from the full electric vehicles? For example, hybrids or fuel cell. If not, what is a consideration behind it?
You mean for Protean or for Evergrande?
For Evergrande.
As far as my knowledge, and everything is on battery EVs right now. But there has a lot of group businesses and a lot of subsidiaries in the group. They're looking at some new technologies, but maybe they're not right now in the implementation phase. Right. Right now, just all battery EVs.
Right. Okay. Great. Thank you.
Okay.
Professor Zhang.
Hello?
Thank you for your patience.
No. I'm enjoying listening.
Thank you so much. We have talked about the new EV development, and also some of the panelists talked about what they're looking to do in China, and also what they've been up to in the UK perspective. Without a doubt, China is the largest EV market on the global scale, and also this market has its own characteristics. So as a distinguished academic, and also at a very prestigious university at Tsinghua, could I have the pleasure of asking you to talk about the status and the prospect of the vehicle electrification in China, please? Because your insight will be very beneficial to other panel members and also to the audience. If you have any slides prepared, feel free to put them up, or feel free to just talk us through it.
Okay.
Thank you.
It's my great pleasure to join the panel discussion. Before I make my points, let me congratulate UKCSAE for their first anniversary. Actually, I am a founding member of JCSAE, Japan Chinese Society of Automotive Engineers. It was founded in 2005, the first Society of Automotive Engineers of Chinese outside China. I understand how many work it involves in the beginning, and you really did a good job, excellent job. Today there are lots of events, very rich content. Congratulations. Let me share my screen. Okay. Okay. Yeah, I would make 3 points. First, China really did a great job in the vehicle electrification. The second is still there are some challenges, the problem remaining. Third, I will give some prospect how China's electrification will go. First, look at this figure. It's from the Global EV Outlook 2020. This is about the PHEV and BEV sales around the world. From 2010, from nearly nothing till today, about 7 million NEV. There's a huge increase. China accounts for nearly half of it. So the market share is clear. China did a great job. And behind that, the charging infrastructure, China also did a very good job. The previous modellist has also talked about the charging in UK. In China, these are 3 statistics. For the slow private charge, around the world, China accounts for nearly 40%. For the public accessible electric vehicle slow chargers, China accounts for about half. For the quick charge, a faster charger, China accounts for 80%. So this is a great achievement. And this supports China's growing EV market. And also it helps to draw Japan into the Chinese coalition. Sorry for this slide. It's all in Chinese, but I will try to explain it in English. Right now in the world, there are 4 main protocols for charge. European, US, Japan, China, all has these different interface protocols. This is not good for the widespread diffusion of electric vehicles. Right now, maybe 2 years ago, China and Japan come close to each other to try to develop new protocols for fast charge. Japan is advanced in the charging technology. China have a huge share in the charging facility. So these 2 countries may come up with a new charging protocol that will facilitate the further diffusion of electric vehicles. And third, China, through the development of electric vehicles, there are some companies coming out with competitiveness. You may be familiar with CATL, BYD. They are all doing quite well in the battery and electric vehicles. Such small company in the beginning grew into huge size and is a player to be reckoned with. Okay, this is the achievement of China in the electric vehicles. But there's still some problems and challenges. The first is there's no world leading brand in Chinese domestic makers. And all the market is domestic. There's no sales outside China. So China may have a large number, but still the technology is not very advanced. And also China is strong in downstream in the number of vehicles, but in the upstream, the key component, and especially in the key materials, there's still a lot of work needs to be done, especially for the fuel cell vehicles. The major key component of materials depends on import, like the PEM, proton exchange membrane, or GDL, gas diffusion layer, or catalyst, platinum supported on carbon. All these 3 key materials depends on the import. So China has a lot of things to do. And for the prospect, let me go to the second slide. Okay, China pursue a different route than others. For example, here is a vehicle electrification strategy of Toyota. Toyota's core technology is hybrid. And this figure is taken from a presentation material of Toyota. They launched the hybrid vehicle in 1997, the first in the world. And from that, they grew into EV, PHEV, FCV. So that's their strategy. It's based on their own experience, based on their own strong point. But China go through a different route and will have a different way forward. As shown in this picture, I reviewed the route we have gone through. Actually, China in the past maybe 15 years, starting from 2000, goes through FCV, HEV, BEV, and PHEV. And this generally follows the world trend around the world, mainly leading by United States, followed by other regions. China also follows the same sequence. But in the last step, the third step, China did really well. China succeeded in the wide diffusion of BEV. Now from now on, what will be the Chinese route? This is what my imagination. The BEV and PHEV will be the main thrust. China will continue to make this as a bulk. Besides this, there will be HEV. This is a transitional, and it is not counted as new energy vehicle. It is called energy saving vehicle, even though it has a battery and motor. In China, new energy vehicle refers to the upper two, BEV, PHEV, and FCV. And for the FCV, we will start from commercial vehicle, fuel cell plug-in hybrid electric vehicle, from the commercial vehicle, and then gradually transit to passenger vehicle, and maybe strongly fuel cell based. And this is a Chinese route forward. And I still have another slide. In the even further future, I think there will be 3 versions of new energy vehicles. The first version is actually EV. All the electric vehicles are counted in. This is first version, maybe 5 years ago. Now we come to the second version. We restrict the scope of EV, just a new energy vehicle, only referring to pure electric vehicle, plug-in hybrid, and fuel cell vehicle. And the new renewable energy should be the upstream energy source. This is the aim, from the source of energy to the downstream, trying to surprise decrease the carbon emission. This is the second version. So the third version, it should be the smart new energy vehicle. The intelligent drive or autonomous drive, kinetic vehicle will combine with electric vehicle together to bring the electrification to the third stage. This is my envision of the future of Chinese vehicle. And for this to happen, China alone cannot accomplish. There are a lot of challenges and risks accompanied with EVs. The companies cannot make profit easily. And so people usually come together, to work together, to form coalitions, allies, and consortiums. There's a huge opportunity in China. So any interest, any participation from abroad is welcomed in China. So that's for my part. Thank you.
Thank you so much, Professor Zhang. If I'm only allowed to pick up like one point of the things I learned during your introduction, I would say the effort both China and Japan put in order to unify the charging standard. Because I was literally speaking to one of my colleagues last week. I said, I'm really worried that the charging standard will never get unified across the globe. So Japan, China, Europe, and America will have their own standard for a very long period of time. So it's really great to see that there's some progress being made, at least between China and Japan. And hopefully through the global effort jointly, we can get somewhere in the near future that we have a unified charging standard. It will effectively reduce the cost every country spend on building and developing their charging infrastructure, and also helps the auto OEMs to better spend their resource on some other aspect on the vehicle or other features, rather than having to stock all the different type of the charging plugs for the vehicles being sold to different markets all over the world. And there's a question came through the Q&A, and I would like to pick it up and ask Professor Zhang if he wouldn't mind. That is around the future cost of the fuel cell vehicle. I think for the EV and the hybrid vehicle, although they are still more expensive compared with a conventional IC engine powered vehicle, but people have a rough estimation about how much it could cost in terms of the initial purchase and also the running cost. But for fuel cell vehicle, it seems like there's less clarity about the initial cost and also how much you have to spend in order to put a liquid fuel in there, and also how is the customer going to access the fueling station. Is there any comments you could offer from that perspective, please, Professor Zhang? Thank you.
Okay. The cost is truly one of the limiting factor for new energy vehicles. After 10 or 20 years development, the BEV have a great reduced cost. That's one driving factor for its widespread diffusion. But for fuel cell vehicle, there's still the great challenge. The key materials is very expensive. The platinum and the carbon fibers for the hydrogen tank. So the price is very high. And so Toyota's Mirai sells for, let me see, maybe 70,000 US dollars. It's very expensive. China trying to pursue a different approach. It is now using a hybrid, electric hybrid, which means a hybrid of fuel cell and battery. Since the battery have much reduced price thanks to the years of R&D, we can use a relatively large battery and a relatively small fuel cell. And so this is a special configuration in the powertrain, and this helps greatly to reduce the vehicle price. So that's why I show China will first from the commercial vehicle, plug-in fuel cell hybrid vehicle, instead of personal passenger fuel cell vehicles. And that's one way to get around it for in the short run.
Thank you, Professor Zhang. And Huayin, are you there?
Yes, yeah, of course.
Would you mind setting the scene for the recent roadmap development in China, and also take it forward and asking the remaining questions to our panel members?
I think talking about the roadmap recently published in China, there's a very clear and interesting direction as well. I think it is pointing to, I think, around 50% of new energy vehicle by 2035, and the other half of the new vehicles will be high efficiency and mostly hybrid vehicles. So in terms of the hybridization, I think in the last few years, there have been a lot of discussions or maybe even debates around the 48 volt mild hybrid systems. So I do want to ask Mike from Marla Powertrain about the 48 volt system, because you have explained about your PHEV and the high efficiency engine concepts. What's your view on 48-volt system? Putting this into the context of the roadmap published in China recently.
Yeah, great question. So 48-volt hybridization is a really cost-effective route to reduce CO2, and we can typically see 10% reduction over drive cycle, depending on the architecture of the hybrid system. If we go for a P0 type system, we're looking at 5 to 8%, and then with a P1, P2 system, we can push that up higher if we have higher installed powers in the hybrid system, and if we can decouple the engine during deceleration events, we can recuperate higher amounts of energy to redeploy that and displace gasoline or diesel use. So from a sort of bang for buck, it's probably the first step that you would take really to reduce your fuel consumption. So really attractive, and we'll see, I think, 48-volt hybrid architectures that are going up to maybe even 20 kilowatts power capability in the near future.
Okay, yeah, that's interesting. And I noticed that you said as the first step, it's going to be, well, for some OEMs, it's going to be 48-volt system. So I presume you're kind of implying that it's going to be a kind of a transitional technology which will move on to, for example, PHEVs or other technologies.
I think that's it. We'll see a spread across fleets of pure BEVs, plug-in hybrids, high voltage hybrids. But I think what would be termed the conventional vehicle will almost all predominantly be 48-volt with some amount of hybridization.
Okay. Yeah, that's a very interesting point. And I guess the deployment and the development of the hybrid technologies in the near future is going to be heavily dependent on the progress of the battery cell development. So the next question I wanted to ask Michael from Ricardo, because you have lots of experience on the batteries, e-machines, and inverters. So, do you think the battery technology in the near future, let's say 5 to 10 years time, the cost of lithium-ion battery technology will drop to a level that will be on par with the combustion engines?
On par with the combustion engine from a cost perspective, I don't necessarily think so, but dramatically reducing in cost further from where it is now, I do believe so. But I guess my perception is cost is a big aspect of it, but the bigger aspect in the batteries is actually the energy density, the physical size of the battery, and the amount of energy and the range that you can get from that. That's what's limiting the BEVs taking over for the hybrids. You know, as Mike mentioned, the 48 volts. The 48 volts is a very cost-effective way of making your internal combustion engine better, perform more efficiently. But the reason why it's the most cost-effective method is that you don't need a very big battery. As you get the bigger battery, the cost benefit goes down, but it also leverages a power battery versus an energy battery. But as we see an increase in the purchasing of the battery electric vehicles, it's going to be more on they can get a bigger energy battery in there, I think, more than being a cost sensitive thing. So I don't think the battery's target is to get to cost parity with the engine. it's to really more get it to something comparable with an energy density more comparable to that of an engine.
Yeah, okay. So there have been a lot of conversations around the battery cell topics. And we've talked about 48 volt and lithium-ion battery cells. And I know, Professor John, you're on the deep end of the battery cell development, and I'm sure you have a lot of insight into that area. So if I may ask your opinion about the future of the energy storage system as a whole. What's your opinion on the lithium-ion, the liquid electrolyte cells and solid-state cells, or even fuel cell technologies in terms of the growth? What's your vision and the development of these technology streams?
Okay, it's a good question, and it's a question difficult to answer because different type of technologies competing with each other right now. Somehow, like 100 years ago, when the automobile is first invented, there's also a period when the different powertrain are competing with each other. The steam engine, the internal combustion engine, and the electric vehicles. Nowadays, similar things happens. Right now, the lithium-ion battery seems to be the one first get commercialized and enter into the stage of commercialization. But still, it has an uphill battle with internal combustion engine in terms of the cost, the safety, and the fuel cell vehicle after the hype, two hypes in the turn of the century. Now seems to be retreating from passenger car, and now is getting interested in the commercial vehicle, especially truck. Yeah. So my first point is there will be a share or division between fuel cell and the lithium-ion battery, depending on the types of car. For the small size, the short distance, it will be mostly BEV. For the long distance and heavy load vehicle, it will be the world of FCV. So in the future, there will be a division. This is one point. Another, even for the short range, the passenger car, still the different technology in the batteries is under development. The liquid electrolyte seems to coming close to its upper limit. And the solid electrolyte battery is under heavy development, leading by Toyota. But it is hard to see. It is hard to say. There are a lot of issues relating with solid electrolyte, either because of the fabrication cost will be extremely high, or there will be other hidden issues. For example, the sulfur-based solid electrolyte, even though it is less likely to explode, but if it is exposed to air, the sulfur dioxide, other sulfur compound will be generated, and it is toxic, even though it is not explosive, it's toxic. People seldom talk about this, but it is a hidden issue. So for maybe 5 to 10 years, we have to live with liquid electrolyte to improve on it. In the same time, the solid electrolyte batteries will be under heavy research. And in parallel, the fuel cell will also develop. So the division between fuel cell and lithium battery is dynamic, depending which technology gets breakthrough, its sphere will improve. So it is dynamic and difficult to tell for sure. So it is one area we keep eye on, keep open. You know, that's my view of it.
Okay, yeah, thank you, Professor Cheng. I know I probably have asked a very tough question, but you've laid out a very clear direction of the future of the energy storage system. And now I want to bring it back to Adrian, if I can. The battery technology have been discussed already, and some of them are more dependent on the charging infrastructure. Some of them may not be so much. So what's your view on the impact of the charging systems and in the next 5 to 10 years? And also, I think we have many providers in this area. What do you think will happen in the next 5 to 10 years? Are they going to be competing against each other, or what will happen in that area?
Yeah, a wonderfully simple question with a potentially complex answer. So I'll try to keep it down to the essentials. I mean, I think the key thing, the big question for me are the business models, and our panelist, co-panelist Tom touched on this. Just as a high-level comment, the first thing I'd say is the technology is there. There's still opportunity to scale up that technology and bring the costs down, but it's the business models that are going to enable the success of these different types of EV charging opportunities. In terms of the charge point operators, you've just highlighted the fact there's quite a few, and it's a fragmented, certainly in the UK, it's a fragmented universe. Inevitably, I think there will be consolidation in the market. There has to be, because only a handful of these players have any kind of regional footprint. A lot of them are quite small. And we have issues around interoperability, which is the other big theme there. I mean, our colleague was talking about the different charging systems, the different specifications across different regions. Interoperability is an example of that. In terms of in the UK, you have to have, generally there are subscription models, so you need to have multiple cards to go and charge your card with different providers. We have to get to a stage where you have interoperability. It just makes it easier on the consumer, and therefore that will drive adoption rates. And therefore I think with a combination of consolidation, more mature business models, I think it'll just help accelerate electric vehicle charging infrastructure, certainly in the UK, and I suspect amongst these other regions as well.
Thank you, Adrian. That's very interesting, and it covers the perspective of the charging providers and the end users as well. And that's pretty much all of the questions probably from my side. And I do notice there are a couple of, again, very tough questions. I think we're close to the end of the day, so we're in a...
Can I just mention something about the charging? Because sorry, I probably should have said it about 1 minute earlier. I think it's just like Adrian said, it's quite a complex topic. Certainly more general economy instead of just basic engineering. I was talking to someone from China National Grid another day, and what he explained to me was the transportation, the liquidity of the transportation industry is the fundamental enabler for for the national economy to prosper, and so the national strategies, they now promoting the new EV vehicles, battery EVs or other form of new energy vehicles, but they will consider. So how to say, so they are, of course, they subsidize the implementation of or the construction of the charging facilities, but they also are thinking about the cost of the electricity as well. This may be slightly different, I think, fundamentally because of the social system and the government is probably quite different in China compared to the Europe. So for just very very good example. So right now in Shenzhen or in Guangzhou, you go to charging station and you have a, if you have BYD, and it costs you about 1.5 RMB per unit power battery, and compared to so if you're using that in the vehicle, that costs roughly about 0.18 RMB per kilometer, and in comparison, the petrol vehicle, that will be half RMB per kilometer. So it's roughly about a quarter to a third. Very, very cheap to run. But in comparison, if you look at the domestic electricity price, it's a 0.3 to 0.7 RMB per unit. And the national grid basically said it's not because the electricity is cheap, it's because the government subsidized the rate. And then when you come to commercial use and industrial use, the price are doubled. So it's 0.8 RMB to 1.5 RMB per unit. So the government basically will consider the use of the vehicle and also the liquidity of the mobility. Basically, they would encourage that to keep as active as possible, and therefore subsidizing the charging station, and also the cost of the energy is essential, basically, to ensure that we're not just buying electric cars, but also we use it as as often as we possibly need to. So that this is very different. Maybe cannot or very difficult to mirror that system in Europe, or particularly in the UK. Andrew, yeah, what's your?
Yeah. I was fascinated when you were talking. I mean, I guess there are different systems, and the theme that struck me while you were speaking, and Professor Tang also talked about, is the role of government. And while I talked about business models, and which are a fundamental aspect of making charging successful in the future, I do think governments have a big role to play in terms of setting the vision and the policy framework to allow the marketplace and business to invest in and grow the infrastructure. And one positive that I take now, and this is specific to Europe, it may be less so in other regions, but certainly in Europe, what you're seeing with COVID-19 are governments pulling together financial packages, resilience packages, based on a green recovery. And therefore you see Germany coming out, for example, investing in whatever it was, 7 billion euros for a hydrogen economy, mandating that all petrol outlets have an EV charging unit. There are lots of examples of that, out of that. So I do think one positive is governments do see an opportunity now to accelerate the energy transition and investment in all these types of new energy technologies. And some of them are being quite forthright in setting that mandate. China's been, frankly, ahead of the game for some time in that respect. But I think that's a positive trend.
Yep.
Yeah, that's very interesting. And yeah, I think today we've covered a number of different areas, various technologies on the component level, and different solutions for the powertrain system, and different aspects for the charging and the user experience. And I guess it's going to be very difficult to just say any one of the technologies will be dominant in the market, or at least personally, I wouldn't hope that to happen. And if I may ask just one simple question to every one of you. Just consider me as someone who doesn't know anything about vehicles or engineering. Just give me one straight answer, hopefully. If you are to buy a electrified car for your family, for your own users, right now, what type of car are you going to be choosing? So let's start from Michael, Mr. Miller.
That's always a challenging question. So I mean, again, it all comes down to what your drive profile is, and I'd say I don't drive cars very much anymore. Certainly not this year. And so when I do drive, it's going to be longer distances. So I'd be looking for an EV, and I am. Will be looking at my next vehicle being an EV, not buying another petrol-powered vehicle or internal combustion vehicle. Again, I don't expect. But it would have to be a vehicle that has a longer range and the ability to seat four. So yeah, so you start in the EV world, you start to narrow that down with just those kind of simple criteria very quickly. So if you want to pick one, then I guess for me, you start to really have to look at something like the Tesla that does offer the longer range and the fast charge times, as well as seating for four comfortably.
Okay, cool. That's interesting. That's clearly quite aggressive, and we look forward to the feedback from you in a few years' time. Experience will be. And next, Mike.
So for me, I have family who live quite far away. So again, I'd want a car that was capable of long ranges. And for me, I think the state of the charging infrastructure would mean that I'd at the moment favour a plug-in hybrid. I guess I'm duty bound to say that, but I see that as a good solution for now. In 5-10 years time, I may cross the room and join Michael with an EV, but for the time being, it'd be a PHEV.
Okay, yeah, that's interesting. And personally, I think I will go for the same option as you, Mike, as well. And next, if I may ask Professor Zhang.
Definitely BEV. The reason is simple. I live in Beijing. In Beijing, it's already very crowded by car. If you want to buy a car, you have to queue up to apply for the right or qualification. But if you buy a BEV or FCV, you are privileged. You don't need to queue up. But at the moment, there's no model FCV available, or even worse, there's no convenient hydrogen station around. So the only choice is BEV. There are quite a number of cars that is impressive. So I will buy BEV. Okay.
Okay. Good. Thank you, Professor Zhang. And for those who didn't know the background, in Beijing, you need, in order to get the license plate, you need to queue, and there will be like tokens for people who are allowed to buy cars, and it's easier to get the tokens for electric cars. And next, if I may ask Tom the same question.
In terms of technology type, I think BEV is probably most suitable. I think it just appears to me as most mature, and the reason I haven't bought one is I see battery EVs as a white goods, and it depreciated too much, and during your ownership, and also the technology evolves too quickly. So if I see the technology improve 10% every year, I tend to wait another year and another year and another year. That's why I haven't had one yet. But in terms of the shape type of the car, I would say similar to a Model X with a sliding door, but not a golf door.
That's very specific.
Just a 6 or 7 seat, good for family. Yeah, but it must be a dual motor.
I thought you were going to say 4 motor.
Well, 4 motor,
One for each.
wheel motor.
Okay. Would you expect an answer from myself?
Yeah.
So I must admit, I'm currently driving the diesel-powered vehicle. But before I bought my current vehicle, I seriously looked into and considered a plug-in hybrid. The only reason I didn't go ahead of actually buying the PHEV was at that time, after I've taken into account of all the government subsidies and all the initial, all the potential benefits, I did my own calculation. I have to own that vehicle from 5 to 7 years to reach the breaking even point, because the initial cost was still much higher compared with a typical IC engine powered vehicle. But in terms of the usability, the typical full EV range on the PHEV vehicle, usually 20-30 miles, will be sufficient to cover my daily commuting route. I only take my kids away to go somewhere, for example, beach or Peak District for travel, occasionally during the weekend. So the PHEV will be a perfect choice to me. But the initial cost, it is something, or probably the only reason putting me off. I'm still feeling guilty about it, because from the environmental point of view, every time when I jump in the vehicle, I'm thinking I'm still polluting the environment around me or around my kids. So for the next vehicle, depending on the cost, and hopefully the cost will get to somewhere very closer to the typical IC engine vehicle. So I'm pretty sure that there are going to be more and more customers choose to accept the new technology.
Okay, interesting. And lastly, Adrian.
So I'm smiling to myself because I envy the freedom of all the panelists to articulate their preference. Being an employee of PwC, and we audit many clients, I cannot be seen to be advocating either a brand or a type of car. So what I would say, what I am comfortable saying is, if a family were to approach me, I would encourage them to go electric in the broader sense, simply because economically it's cheaper. And you'll be doing your bit for the environment. I'll position my response that way.
Okay, that's very professional and political as well.
Oh, by the way, apologies, Adrian. I just realized I jumped the queue. I saw that all the panel members have already answered the question. Sorry about it.
I enjoyed listening to all of you. Not a problem. No need to apologize.
As soon as Huayin threw out that question, I'm thinking, yeah, I'm still feeling guilty for the choice I made a few years ago.
Well, I'm not sure about that, because if you, I guess everyone could ask, the well-to-wheel emission, is it really, well, we need the evidence, I guess, to prove that diesel is more pollutant than electrical vehicles right now. Well, at least I think this is probably going to be a hot topic in the industry for now. But maybe, yeah, after seeing all of your choices, from my perspective, I can tell that most of you guys have chosen electric vehicle. And I think only Mike has chosen hybrid. I take that as a kind of the engineer's preference or personal interest, because Michael, you worked on new energy vehicles, and Professor John, you obviously work on the same thing, and Tom and Adrian, and Mike, you've done a lot on the hybridization. So yeah, it seems to me that this is purely dependent on what we do as engineer or professionals in the industry, instead of a pure rational decision. But I think everyone has different opinion.
Sometimes your job, your profession encourage you to adapt early, or actually hold you back. I have to say, a few years ago, I thought BEV is nowhere, and X, Y, Z, and I wouldn't choose battery vehicles because my concerns with the with the weight, with the safety, and with the lack of charging. But now looking forward, I actually think things has moved on quite a bit, and my profession is now telling me that it's the time.
Also, my take is there's a very clear that no single solution, no single technical solution, whether it's PHEV or fuel cell or the BEV, will fulfill all the requirements. And also our choice probably going to be different in 5 years time, in 10 years time, as technology develop advance. And also even we're talking about changing of different location, depending on the local public transport infrastructure. So your choice probably going to be quite different from the choice we made right now.
Yeah, I mean, the one thing I would add on to what you've just said is, if you look at the impact of the energy transition, there is no one preferred technology. There's a multitude of technologies out there, from carbon capture, hydrogen to electric vehicle charging, and some hydrocarbons. The fuel mix, the energy mix is just going to become more diverse. So I don't think there'll be a dominant winner.
Yeah, I totally agree. Some people say there's a competition, the technology are competing. There must be only one or a couple of winners in a few years' time. But personally, I think all those existing technologies will coexist for quite a period of time. But of course, how long they will exist will vary from market to market, from country to country.
I think it will also be a generational thing. I think my children's generation will accept electric vehicles without question, and it may seem the only rational choice to them, whereas people of my age will still hanker maybe for traditional powertrain.
I totally agree. I sometimes making jokes with my kids. I said, at the moment, if you see some people driving like a super electric vehicle or like a Tesla Model S, they must be rich people. But maybe in 20, 30 years time, only rich people would choose to drive an IC engine powered vehicle.
Yeah, and if I could just chip in, I talk about the well-to-wheel approach on the emissions. But I guess we even go beyond that, even though I'm a very strong proponent of the BEV, certainly over the hybrid for most aspects. But when we start to talk about well-to-wheel emissions, probably not much different battery to ICE. But you talk about local air quality. Local air quality will be better with the battery than it will be with the ICE. The area around the car will be worse. So it's all in where the pollution goes into the global system. Maybe not much difference at this point. Into the local system, BEVs are still better. But then you go beyond that into recyclability. We've been dealing with the stuff in internal combustion engines and managing mostly just metals for a very long time. Now you throw batteries into the mix and the recyclability of the lithium-ion batteries. We can. I think we have better options to reuse end-of-life lithium-ion batteries than there is to recycle them. We don't really know how to recycle them yet. There's a further environmental impact on the wide use of lithium-ion batteries and how that's going to work after their life is complete. So what the overall impact is of the vehicle, our mass adoption of EVs, is still an open question.
And I think also the air quality with latest emission standards, that's becoming less and less of a differentiator.
Yeah.
I think this is an excellent discussion. I have to perhaps raise this last question. I would like to take the opportunity, a bit of privilege on this panel. Now, we know that the British government are discussing to stop the hybrid, including all combustion engines. Initially, in 2035, now being advanced by the proposal to 2030. So what is the possibility, feasibility to do so? When you guys are people working in the high front lines of the technology development, then whatever in the end will be delivered by the industry. So what are your views?
If I can jump in initially, I would say it's a nice target. I'm sure it's, I will say, politically well thought through. But if you talk in reality, 2030, 2035, you're talking 5, maybe 7 iterations of vehicle development to redo the entire fleet of vehicles for every company. And shift the perspective of all of the market. And I just don't see that happening. I see maybe not dissimilar from what China has done, where China has said, we want to see 5 million electric vehicles by 2020. Didn't get there. But it's a good aspirational target that pushes things forward much, much faster than setting reasonable targets.
Mm-hmm.
So, but I don't think we can legitimately do that with the technology and the society as it is now. Certainly, as Mike had referenced, we still have a generation of people that still want to have that convenience and flexibility of a internal combustion engine. And I don't think that in 10 years' time, we're going to have that level of flexibility in an EV.
Okay. Okay.
Yeah, I think it's potentially even a dangerous step in as far as you may dissuade people from changing their vehicle. So they may buy a vehicle in 2029 with one of the last iterations they can get of conventional technology, and then we'll just keep that. So it may have a detrimental effect on how quickly newer and cleaner technologies are introduced in the longer term.
Right. Yeah. Good. Yeah.
Yes.
So
Very interesting.
Yeah.
Adaptation of any major industrial change is never going to be a linear process, right? You always have to, it always seems to like the industry or the society is struggling to adapt, and all of a sudden it reaches a point, and then you see the hockey stick diagram coming up. And a typical example was about, it's about a banning or not banning, but changing from using plastic bag to a reusable bag, right? One, there was no real cost penalties to the general public, and people's awareness has reached that tipping point. People just all of a sudden they have decided, I'm not going to reuse, I'm not going to ask for a new bag from supermarket. I'm going to reuse what I have. And the usage is reduced 80% in the second year. And I think comes to the EV is, and we have, well, in China, I'm not quite sure what's going on in Europe right now, but in China, at least, the government is very clear. The cost parity of two things is the cost parity for the new EV vehicle, and also the cost parity for the energy needs to be, we need to reach those 2 points by 2025. So it becomes a not economic choice by the consumer. It's a social and environmental awareness choice. So at that point, I personally prefer that I started to see the changing of the growth curve becomes a tipping point. Sorry, it becomes a hockey stick going upwards. 2025 is not very far away compared to, well, based on how fast the last 5 years has gone.
Yeah, I was just going to briefly say, again, it was a great question. It was a mischievous question, I have to say, and quite rightly so. I mean, governments, so I can understand, particularly from the automotive industry and all the implications of supply chain, bringing forward that timeline has significant repercussions for business models and automotive players, investment, etc. I get that. I guess from the government perspective, they're there to set the agenda and the aspiration. And the two things I would say is, one, there's been a significant change in sentiment about the energy transition and climate change in the last 2 years. It's a European thing, but you look at the impact of Extinction Rebellion, activities of Greta Thunberg, etc. There's been a real groundswell of consumers about taking much stronger action towards climate change. And at the end of the day, one of the big drivers of the energy transition is the consumer. So they're looking for sustainable solutions. I think governments are partly responding to that. But I also think, interestingly enough, I hate to mention this, it's something I find very awkward, the whole Brexit debate. Brexit at the time was all about consumers having enough of big government and being told what to do by governments. What I find interesting now is, because of COVID-19, governments have been given a mandate to take decisions for consumers and society, and on a much larger level. The whole implementation of lockdowns, quarantines, and governments are being empowered to take that action, and consumers are encouraging government to take that action, certainly in Europe. And I do think there's an element in terms of the whole energy transition, climate change. Governments are empowering themselves to set the direction of travel. So even though 2030 will be challenging and has implications for all of us, in a way, governments have to set that agenda. Just a thought there.
Well, talking about the policy, if we come back to the electrification, I personally came to UK about 10 years ago. I still remember at that time I did a master thesis about the comparison between electric vehicle and traditional vehicles. And I think one of the things, I probably wouldn't call it mistake, but I think at the time when I was doing the report, I was mostly using the data at the time. For example, the energy sources, the efficiency, the cost. I was using those data at the time to predict the future or to make the comparison. So we try to bear that in mind now. All of those data that we can collect from the industry and from different countries right now I would probably question whether we should be using those data to make the policy for the next decade or two, because I'm pretty sure those numbers will change. Well, at least I hope, right? I don't think I'm fully qualified to say that which policy is right or wrong, but I think we'll probably just need to keep our eyes open to whatever that may happen in the industry and the surrounding technologies like charging or the energy sectors, and to basically keep our eyes open and to look forward to whatever is going to happen in the future. At least that's what I'm trying to tell myself. And if we so probably just to wrap up, and I know we have spent too much time on this conversation. So just to give a bonus to whoever is left in the audience now. So if every one of you could give one advice to the automotive engineers in the industry now, what would you give to them? I'll probably do it from the other way around. I'll start from Adrian, probably.
Great question. And I'm not an automotive engineer, but I'd guess the analogy I would make is with petroleum engineers, in terms of an industry that's going through significant change, shift from hydrocarbon to new energies. I'd say build up your digital skills, everything from coding to understanding to working more agile, quicker, innovative ways of working. That's the advice I would give. Okay, that's interesting. Seems we will be going back to the first panel discussion about digitization. And next, Tom.
Yeah. So when when there's a multiple technologies are competing in the middle of a revolution, I think the important thing for the engineers and also the business decision makers is to focus on the consumer value, because many times, and personal experience as well, the strategies or the decision made by a business or even by the engineers could be misguided based on what they believe, based on what they have, based on the perceived a technical advantage, but they may not reflect the actual market demand or the consumer demand.
Okay, Tom. And if I may ask Professor Zhang as well.
I would suggest the automotive engineer to be prepared for the great transition. The industry is undergoing an unprecedented transition towards electrification and intelligent or autonomous driving. An engineer should be flexible to get into the new technique, to learn some new trick. In the academic, in university, we already shuffle up or update our curriculum to greatly expand the courses on electrochemistry or artificial intelligence. There will be less and less research and design task or project on the conventional vehicle, but will be more and more research and development task on electrification or automation. So an engineer should be prepared for the great transition.
Yeah. Okay. And Mike.
Yeah, my advice would be to question everything. So there are many perceived wisdoms in the automotive industry and rules of thumb that engineers use, and people who profess to be experts. And I'd say never be afraid to question them, and go back to fundamental principles and examine whether what you're being told or the data you're being given is sensible and useful. So that'd be my key recommendation. And I think the second one is never be afraid to have a go at something as well. Actually, fundamental engineering principles carry across the disciplines. In our business, we have a lot of engineers with expertise in IC engine design, but we can transfer those same people quite readily to battery pack design or motor design. Good design and mechanical analysis and thermodynamic analysis actually transitions quite readily across the different disciplines.
Okay, thank you, Mike. That's very useful. And Michael?
Yeah, I really want to leverage off what the other guys have been saying, but the single biggest thing is to be maintain an open mind. As Professor Zhang had mentioned, we're in a big revolution of the automotive industry right now. New materials, new technologies, new processes, new models of behaviors. People may be driving less and less, and autonomous vehicles, things like that, taking that stuff over. It's really critical to keep an open mind and not get bogged down by the inertia that the industry has built up over the 100 years. To stay fresh on technology, always looking at all of the options and making sure that as these options are going forward, that they're going to last. So yeah, I think it's really just jumping off of what certainly Professor Zhang and Dr. Bassett said.
Okay. Thank you, Michael. And Professor Guo?
I was going to ask, actually, would you kindly allow me to offer a piece of advice to our audience, please?
Yeah, of course, you're a professor.
Well, it was well said by all our panelists already, and also it's quite a lot of information for our audience to digest. So my advice is actually quite simple and straightforward. Please stay in contact with us, because a lot of questions were actually asked during the discussion. Many of the questions are really, really good. So please take a record of this email address and also our official. Can you actually see that? No.
No.
Is it better?
Just.
So please do feel free to get in touch with us at the UKCASAE on any topic you may like to discuss in more details, and we will certainly take your comments and suggestions on board in order to arrange future events accordingly. So on the top is our official email address, and at the bottom is our official WeChat account.
Okay, thank you, Professor Guo. That's very well done. That's exactly what we wanted. Lastly, I'll probably ask the same question to Professor Xu as well. You're a very well-known professor in the industry, so if you could give us some advice as well.
I think technology is advancing in a speed that beyond our imagination. There's a famous saying or belief that engineering is always behind the plan. No matter what we had, the training today was good about how to do the project management. But I work at the industry in Jaguar Land Rover between 2000 and 2005 for 6 years. So I had the same feeling that meeting the target in engineering a product is very often behind the schedule, and we have to press on, work extremely hard to make the target. I'm sure I can see Michelle's, Michael is smiling. He probably agree with me. Now, however, we have to believe there's a lot of unknowns in science that we perhaps have not fully explored the limit, even for combustion engines. We heard about the belief that the engine will be dead 10 years ago. 20 years ago, we already had a debate on whether we should have gasoline engine or diesel engine. And 10 years later on, we heard that the engine will be dead. Now, many people believe that we should really get rid of the combustion engine now. But here, we still hear news, breakthroughs, and development from people like you. Mike also been working on the front line, and many of you are working on that research and development. So we will see more and more progress, and gradually still moving forward. And at the same time, I have although I started for combustion engines, started from 1977. That's my first choice for this subject. Okay, when I entered my university entrance exam, I choose combustion engines. That is where I started my undergraduate course. Now, over the 24 years, I've been working on combustion engines, nothing else about engines, but now moving on electrified powertrain unit. But still, there's a lot of development perhaps on electrified powertrains. Combination of both will make the engine even stronger. And at the same time, we are looking forward to the new breakthroughs on battery technology and hydrogen eras. So there's a long way to go for all of us. For sure, there's plenty of things for us to do. All of us here have our job as responsibilities. I think it's quite exciting at this time of the year, the years. Now we see the transitions, and so a lot of new choices before me. So ask the audience or the panels earlier, it's quite good to see the diverse choices for different reasons. So that is my answer. Okay, as long as we work on it, things will move, keep moving, and the vehicle technology will advance all the time in different aspects.
Okay, thank you, Professor Xu, and thank you everyone who have been in the discussion and have been in the audience in this session. And if I may just use a simple sentence to summarize what we have given to the automotive engineers as advice, is just it's going to be a great time for the engineers. We'll see a lot of new things, new technologies and topics. So whatever happens to the companies, whether it'll go bust or whatever, we will enjoy. I think that seems to be the suggestion that everyone is giving. And thank you all again. And this marks the closure of the panel discussion. And I think, sure, we may want to go to the next slide, and I'll hand it over to Professor Xu. Thank you all.
Thank you.
Okay. So, you want me to say something now, or Xu is in charge?
Yeah, I think it's going to be the end of the whole annual conference.
Right, then I really would like to thank everyone. And we all agree this is the meeting now. So great. It has been a success. As we see now, we still have 100 people around on the line. It's already midnight China now. And we had a great opportunity to hear addresses from so many IPs, distinguished guests, about your vision, outlook for the collaboration between the UK and the Chinese automotive industry and academia. So we have learned a lot of great deal amount of information today for the discussion panel and the trend of development for the future. And so the interaction and during the meeting has been very informative and effective. And I hope this will need to follow up, create new opportunities for the further collaboration and cooperation. So I hope you all enjoy the meeting. So I also heard earlier that Professor Zhang mentioned the first Chinese automotive society run outside of China. And also we heard from chairman of the Germany, the France, saying that they were pretty new, 3-4 years. We knew as well. But at the same time, I also said that our society was initially founded in 2002. So I think many of you may have not been so clear about the history. I have to say a few words of this, okay? I just brought up by the dialogues discussion. That we started this society in 2002 when I was a Jaguar. Okay, and that time with people within Ford and the Jaguar formed the society. Actually, we built the website in 2002. The logo we use today was designed in 2002. But at that time, we don't have this platform like today. Wonderful IT technology allow us to use this platform to do such a good job. But I really like to say thank you for everyone for this, apart from this big thanks for the panelists, for the guests, but I really would like to thank Huayin, Cheng, Xu for the excellent leadership in the work of the society for so long, especially for Cheng. He has spent a tremendous of time on organizing this event. Okay, Cheng and others. We have started this planning of this today's meeting 2 months ago almost. Initially, we thought about end of September, but I think now this is the perfect time. For almost exactly this 1 year since the foundation formal foundation ceremony in London, and so this is really a great job done by you, Cheng, and of you, and many of you, not only, but also like Lily behind the scene. She has not spoken yet, but I will know that she spent a lot of time supporting us. As Bao Ran, Dr. Bao, he has been working very hard behind the screen and doing all this organizing work and monitoring the progress. Now, you can imagine now behind this scene, there's many people are working, supporting this operation of this conference. And Yanping being very kindly started its support, help from the beginning, and Yuping and Professor Gou Yue has been very active, making this event possible with others. So without your hard work, and this meeting of today would not be possible, not have been possible, okay? So really want to say thank you. And many of you, if I miss any of you being contributing to this meeting, I'm very sorry. I cannot, otherwise the name will be too long. A list of the name will be too long. But I really want to say, wish you all the best, health and happiness in life, and the complete success in your work. And a lot of collaboration should follow up. I hope we met a lot of good people we first time we maybe, or we met before. So big thanks. And we should have good, nice weekend. Now, this is the first of this weekend, but tomorrow the weather is good. I think the weather I show you in my screen now it's back. I don't know about the other area of the UK, but here at Birmingham now it's beautiful sunshine. It's exactly the weather I showed you at the start. Okay, thank you very much again, and see you in the near future. Okay, back to you, Huayin, and see you.
Thank you very much. Thank you for joining this event. And then at the end of this, but not at last, normally, like say last year, we will have a pub where it's like a meal together, it's like in London. But because we have COVID-19 and these issues, so it's been changed to virtual pub. I know it sounds a little bit weird, but please bring your drink and prepare having a chat with the engineer society with other engineers. Just feel free to join us. The QR code is here, and then Dr. Lin is preparing this virtual pub. And enjoy.
Thank you all.
Thank the team and the people behind, and the interpreter has been doing an excellent job.
Yeah, thank you to the interpreters.
Yeah.
Thank you. A huge thank you to all the speakers, especially the panelists this afternoon. And thank you for your patience in bearing with us for the delayed schedule. And that is really appreciated. And also the same goes to our audience and the team. Thank you. It's been a pleasure.
And also, if you want to join this virtual pub, just feel free to click the link in this message box. There's a link, UKCSAE hold just a note. And then you just click it, you can go to the virtual pub room.
All right.
If you have any problem, just let us know. I will stay here. Feel free to transfer to another room.
Okay.
You're in the pub.
Bye, everyone.
Bye-bye.
Bye.